Hello everyone, my name is Zhounuo, and I'm here not to talk about global warming or AI technology, but a strange topic, light. Do we all recognize this man? The man who was hit by an apple and resulted in the discovery of gravity? Well, his name is Isaac Newton. In the 17th century, there were many scientists experimenting and making discoveries about light, including scientists like Isaac Newton, who is best known for discovering gravity. However, it is another scientist who is called Thomas Young, who didn't need to have an apple to fall on his head to make the discovery, who I would like to tell you all about now. So let's start from the beginning. Thomas Young. In 1801, he established an experiment called the double-slit experiment, which is about light behaving as a wave. Thomas Young's double-slit experiment is a classic experiment and is easy to understand and to set up. Normally, when the light passes through a thin slit, the expectation will be the light forming a light strip on the screen. But in this double-slit experiment, there are two slits in front of the light source, and what we expect to see are two light strips. But what actually is shown in the reality is an unexpected row of lines. These unexpected row of lines is caused by the interference of wave. When two waves meet and cross each other, the crest of two waves combine to show a row of light spot, which we call the interference pattern. This result shows the light has a feature of wave. Because it can interfere, light must be a kind of wave. After these unexpected results, the only thing that scientists can define is that the form of light is both wave and particle, so-called wave-particle duality. After this realization, scientists also found out that not only light, but all microparticles like electrons, which are tiny particles exist in every substance in our world, have wave-particle duality too. Now let's fast forward all the way to the late 20th century. Scientists still want to go deeper and explore more about the way the light behaves. Therefore, many scientists were curious and wondered what will happen if only one light particle were to travel to a double slit. They predict that a single light particle will not be able to travel to two slits at once, which means that there will be no interference happening. Imagine if you have a ball and were trying to throw it to two holes at the same time. Impossible, right? The ball cannot split itself in half. Well, unfortunately, the amount of light is difficult to control. So scientists turned to electrons instead, which have similar properties to light, but are far easier to control. So if there's only one electron traveling to the slits, what will be shown on the screen? Two strips or multiple strips? Particle or wave? When the scientists fired the first electron to the slits, the screen showed a single dot. One electron creates one dot against the screen, just as expected. However, when the scientists fired more than one electron, one after another, the screen showed an interference pattern, a row of lines just like the original double-slit experiment. This result, the screen showing an interference pattern, was surprising and confused many scientists. Essentially, what it suggests is that the electron being fired to the slits interferes with itself. It seems to split into half and collide with its half. Sounds confusing? It is. Now we reach the most significant part. Because of the illogical result that the electron can interfere with itself, scientists then tried to observe closer. Why? Because the scientists were keen to figure out how the electron could possibly interfere with itself during the experiment. To do so, they placed a sensor in front of the slit so that they could see which slit the electron passed through. If the sensor shows that the electron passed through both slits at once, it means that the electron split into half. However, when the scientists carried out this experiment, unfortunately for them, they made even more illogical discoveries. What happened was that when the first electron was fired, the sensor shows that the electron only passed through one slit at once. But when the scientists continued to fire electron one by one, the expected interference pattern changed. Instead, the screen showed two light strips formed by dots. Then the scientists repeated the experiment with the sensor turned off. The interference pattern, the row of lines, came back. This is sensor on, and this is sensor off. The strange thing about this experiment is that the result actually changed based on the way it was observed. It seems like the electrons were conscious, knew that they were being watched, and didn't want the scientists to know about their secrets. It's like when you're trying to hide from your mom that you were playing video games instead of studying when she suddenly comes into your room. In fact, I doubt if you can dodge from your mom as fast as these invisible particles at this moment, because there's no way that the scientists can find out whether the electrons are studying or playing video games. In terms of explaining this result, scientists have done a lot of brainstorming and have had a lot of arguments. There were two main views of this strange phenomenon. The most authoritative scientists in this field were in Copenhagen. They're considered the most authoritative as their interpretation seemed most reasonable. However, there are other scientists around the world who challenged the Copenhagen's interpretation. The most well-known of them being the world-famous Albert Einstein, as well as Erwin Schrödinger, who is best known for his half-alive, half-dead cat, a cat which I will tell you about in a moment. So, what did the Copenhagen scientists say that made these two big scientists strongly against them? Well, they basically said that the world is made of uncertainty. They've declared a theory called uncertainty principle, which is very sophisticated, but we can still use the double-slit experiment as an example. If you are testing an electron as a particle, then it has more chance of being shown as a particle in your result. However, if you are testing an electron as a wave, then it has more chance of being shown as a wave in your result. Essentially, the way you test something changes the form of itself. Sounds uncertain, right? However, this statement, the world is made of uncertainty, didn't ring true for Albert Einstein. He disagreed because he felt that, as normal people do, that all science is fact. It cannot be changed by the way it was observed. Famously, he said, God doesn't play dice, meaning that everything is objective. Erwin Schrödinger, who is another famous scientist in opposition to the Copenhagen scientists, theorized a modern experiment called Schrödinger's cat. It's basically about a cat in an opaque box, a box that you cannot see into, with a mechanism inside that has 50% chance of killing the cat and a 50% chance of not killing the cat. The conclusion he gave, according to the Copenhagen's interpretation, is that this cat is now half alive, half dead. Because we cannot know whether the cat is alive or not unless we open the box. In other words, we see it. Now, some people might easily accept that the cat is half alive, half dead, but for Erwin Schrödinger, this is totally illogical. He felt that his experiment involving the cat showed significant flaws in Copenhagen's interpretation. Another analogy used to criticize the Copenhagen's interpretation is the analogy of the missing moon. At night, we can behold the moon above us, appearing stationary in one location. But what if we turn around and stop beholding it? According to the Copenhagen's interpretation, this moon is now anywhere in the universe, because we can prove that the moon will still stay in that same spot if we stop observing it. Just like you can't know whether the cat is alive or not unless you look at it. However, of course, basic logic dictates that it will still be there. It is totally illogical to think otherwise. In fact, what I've just talked about started stepping into quantum physics, which is something extremely intricate and not many people understand. So if you feel scared or confused, then I'm sorry, but please don't worry yourself. What I've been talking about won't alert your reality. It won't change the taste of that cheeseburger you might eat for lunch or make your toothpaste taste sour. The only people who that might happen to are the scientists who are tackling this mystery head on. Oh, and trust me, they are even more confused than you are right now. With every new idea comes the new unanswerable questions and dilemmas for them. So anyway, if you didn't fall asleep or snore throughout my talk, then congratulations. However, I do think that you all should consider the study of quantum physics. Who knows? Maybe you're a secret genius and could end up with a Nobel Prize. Maybe you will answer some of the questions that the scientists have been asking for centuries. Maybe you're the one to figure out whether Schrödinger's cat is real dead or not. Me? I couldn't. I fall asleep and wasted my time sleeping while researching about these topics and experiments. You? Who knows? What I've just covered today is only a small part of the infinitely mind-bending but puzzling, charming topic of quantum physics. A topic so full of contradictions and uncertainty that the scientists cannot help themselves but keep coming back for more. So what I want to leave you with today is this: don't be afraid, be curious. Thank you.